Hello everybody. Welcome to Dr.K.Liu Maths channel. This question is from Edexcel, Further Maths A-Level Core 1, 2023. Okay, this is a rate of change problems. Let's look at this question. Water is flowing in and out of a large tank. Initially, water is at 10. That is when t equal to 0, v equal to 10. The rate of flow of water is modeled so that the v is the water in the tank at the time t minutes after the water beginning to flow. Water enters this water in of 10 at the rate of this input, and that water leaves the tank at a rate of proportional to the volume of water. That means proportional to a constant k. That is therefore let's look further more. Given that when t equal to 0, the water in the tank is decrease. That means dv over dt at t equal to 0 equal to -3. Okay, by the first part is so that the volume water in the tank at t minutes should be modeled by dv over dt equal to 3 minus 4 over 1 plus e to the power 0.xt, then minus 0.4v. By the properties of the rate change of v, dv over dt should be equal to water in, enter, minus water leave. That means water out. By using this, we can conclude that this is water in. And minus the water out should be proportional to the volume water in the tank. That is proportional kV. That is the rate change of equation of V. And when t equal to 0, the V and the dv over dt should be equal to -3. Then we can put all the stuff into this equation. -3 equal to 3 minus 4 over t. That's 1 plus minus k. That initially v should be the water should be have 10. Then use this one. I calculate the value of k equal to 0.4. Therefore, dv over dt should be equal to 3 minus 4 over 1 plus e to the power 0.xt minus 0.4v. Yes, and determine this value. And here I first use for part B. And d tangent arctan means this one. I like to use this theta. This is actually equal to 1 over. Okay, I use x. I go back to use x. This 1 plus x squared. I think this can be. You can look at this formula from your formula workbook. Otherwise, I can prove for you, but I know in Edexcel should be this formula version is provided. Okay, here I use chain rule. dt I change arctan e to the power 0.4 power to 0.4 t. Here I change e to power 0.4 t. Okay, the first part, this is the first part. I can apply the formula here. That the result is 1 over 1 plus e to the power 0.4 t all square. The second part, you just use the ordinary formula. That is 0.4 times e to the power 0.4 t. Overall, the answer should be here is equal to 0.4 e to the power 0.4t over 1 plus e to the power 0.4t all square. Yeah, this is the answer of the part B. And also, hence solve the differential equation. Now I write down the differential equation here. The differential equation, yeah, here. We are here still doing the part B. Okay. And next step we can see that, yeah, I move that dv over dt plus 0.4v equal to 3 minus 4 over 1 plus e to the power 0.xt. And the integration factor here should be equal to e to the power integration of this e to the power integration of 0. dt. That is the integration part factor is e to the power 0.4t. That, and next step we multiply both hand side by e to the power 0.4t. This part is 3 times e to the power 0.4t. This part is 4 times, yeah, e to the power 0.4t. For the denominator here, I write down like that because one part we have concluded the answer. Yeah. Then for this part, for the right hand side, left hand side of this part, this can be changed to d over dt, d something, e to the power 0.4t times v. For this part, this is 3 times e to the power 0.4t minus 4 times e to the power 0.4t over 1 plus e to the power 0.4t all square. Then integrate both hand side. Integrate both hand side. The right hand side should be equal to e to the power 0.4t v. The right hand side here is 3 over 0.4 times e to the power 0.4t. This part we can see that differentiate this. Here. This part actually equal to arctan of this one. Arctan of this one. I write this arctan e to the power 0.4t plus c. And let me see, there may be some constant. Let me see. Oh, I have to write over the factor. Therefore, there should be 4 over 0.4. Then multiply both hand side. Okay, I think I put value here. Put t equal to 0, v equal to 10. Then this should be equal to 10. This is 1. Then the right hand side is, the left hand side is 10. And for this, put 0 equal to t equal to 0. This is 3 over 0.4, 7.5, 1. And this is 1. Arctan 1 is pi over 4. That is minus 10 over pi over 4 plus c. Then we got the value of c. c is equal to 2.5 plus 2.5 pi. Finally, v is actually equal to, I better to use copy and paste tools. Yeah. And multiply both hand side. Multiply both hand side by e to the power. Then we have v equal to, that is 0.5 minus 10 times e to the power negative 0.40 arc10 e to the power 0.40 plus 0.5 plus 0.5 pi times e to the power negative 0.40. That is the final answer of t. So crazy, it's very complicated, I think. Okay, that is the answer of the second part. Okay, let's look at the last part. Determine the equation for the volume water in the tank at time t given. Okay, I think I solved these questions. Given your answer in the format of this one. Yes, this is for part. Yes, so crazy. I cannot believe this one. Actually, this is part C. Okay, for last part, okay, I understand the format of this question. After 10 minutes, the water volume in the tank is 8 meters. Erase the model is in light of this information. Okay, I think I put the t equal to 10 into, that is last part D. I think the part B should be, that is C. That is C part. Should be C part. Or part D, I put t equal to yes 10. Then v is equal to 0. I think here I only use calculator. Okay. This I got the answer is 0.4053. This is much less than the given answer 8 liters. So my conclusion is that the model is not very accurate. Yeah, this is my conclusion. Because if the model is correct, then it should be approximately equal to 8. Okay, but anyway, I hope guys can enjoy this video, and if you found Dr.K.Liu Maths channel is